Good morning, everybody. We're talking about logarithmic parent functions. This is going to be the eighth parent function. This is going to be the eighth family of functions that we talk about. Logarithmic is a very weird word, and for the most part, it's going to be log is how you're going to refer to it almost every time. Okay, log is the same thing as logarithmic, but we don't really like to say logarithmic. We pretty much just go with log. Now the parent function, which would be the simplest form of the function without anything else, is going to be y equals, and this one's a bit strange because we have a lot of letters here, okay? It's going to be lowercase l, lowercase o, lowercase g, literally the word log, then it's going to be a lowercase b, but it's not going to be a regular lowercase b. It's going to be a subscript lowercase b. It's going to look like this, okay? It's kind of like how you have H2O. It's this subscript. If you guys are in chemistry, you should be relatively familiar with it. So this b is a smaller b that is down below, and then we have x. And as you can see, the b is smaller than the x, and the b is lower than the x. Okay? So this is our parent function. The log is completely standard. It's really obvious what family a log graph is because it literally says log for you. So that is an easy question. We do have this b here, which is very similar to how we had it before with exponential graph. So right below this, what I'm going to do is give you guys kind of like the extended version here, right? The transformation version. We might have it look like this. Y equals the log of b, parentheses, x plus h plus k. And so we have very similarly a whole bunch of stuff that we already know about, right? We know that the h moves us left or right, opposite. We already know that. We know that the k moves us up and down. We know that the b tells us growth or decay. So it's all the same stuff. Obviously, growth would be greater than 1. Decay would be less than 1. So like I said, if you're feeling good with the exponentials before you code to logs, then a lot of this is deja vu stuff, okay? Now, the way that logs work, what a logarithm is, I think it's easiest for me to kind of give you guys an example of, if you think about a square looking like a U shape, and then a square root looking like a U shape on its side, you know? Doesn't really have this yellow part, but they're very similar shapes on its side. The square and the square root is the same thing as the exponential and the log, okay? They're related. They're technically called inverses. They're kind of like opposites. And so basically everything we know about exponentials is going to be very similar with logs. So check out this graph on the right. This is the one we should know how it looks, right? This is an exponential graph where b is 10 because we have the power of x. And so we have an asymptote at 0. Again, I'm just doing a squiggly line so that you can see it on top of the x-axis, just to make it easier for you to see. It's really still a straight, flat line. It's not actually a squiggly line. And then we have a very low graph slowly creeping away from the asymptote, and then right about 0, it is going to rocket in the upwards direction. That's our exponential graph. Now, our log graph is going to take everything about this graph, and it's going to do the exact opposite or the exact inverse of it. Okay, and so to start with the asymptote, If our asymptote is a horizontal asymptote for exponential, I'm sure you guys are already 2 steps ahead of me. Your asymptote is going to be a vertical asymptote for your log graphs. Again, this is a totally flat line. It just is easier for me to draw so that you guys can see it if I use a squiggly line. I guess alternately I could try to do something like a highlighter. Yeah, I mean, it's still a totally flat line. Now, our exponential graph, goes from left to right, looks like this. Obviously, our graph cannot do that because we can't cross this asymptote. Okay, and so what we're going to be doing is we're either stuck on the left side or the right side. Over here, we're stuck on the top, not allowed to get to the bottom. Same idea. We're going to be stuck on the right, not allowed to get to the left. Okay, we're going to be stuck on the positive numbers, right? Because this is the positive side. So we're still going to stay on the positive side. The way our graph looks is it's going to go from low to high, and it's going to have a very similar shape. Right along the asymptote, and then right about 0, it's going to take off. And all of the same things are true. Okay, this is getting closer and closer and closer and closer to the asymptote. Over here, it's going straight away from the asymptote, and it is going to the right very, very, very fast. This is increasing the whole time. This is also increasing the whole time. A little bit different, though. This graph is growing extremely fast at first, and then it's going to start to cool off once it kind of goes up. Whereas this graph is going slowly at first and then extremely fast second. So it is kind of like a reversed order of whether you're going up and then right or right and then up. But the last thing that I'll say, is that both of these graphs only have one asymptote. Okay. A lot of times the issue that kids have is once they've seen an exponential graph and a log graph, they're going to start thinking that there's like 2 asymptotes and that this graph is going up and is stuck by, but that's not the case, right? There's no horizontal asymptote here. It's going to keep going up, and it's going to keep going up, and it's going to keep going up. Now it's slowly going up, but it's going to keep going up. And that's our log graph. Obviously, B is right here, but we need to talk about that, okay? I told you that there'd be a small little b next to the log. And the way logs work is kind of the same way a square root works, right? So if I write all of my roots here, square root x, cube root x, fourth root x, the square root is weird, and you probably know, hardly even think about it. But there should be a 2 there that we don't write, that we don't need to write, because we know if you see a blank one, it just means a square root. And the reason is we're writing square roots about 90% of the time. And we're writing cube roots sometimes, maybe like 8% of the time. And quarter roots almost never show up. And so because we're using this 90% of the time, we just try to save a little bit of time and not write the 2. Literally just because it would be annoying to write the 2. So we just say, yeah, okay, we'll just leave it blank and we'll know that. Okay, it's the same thing with logs. In the real world, when you use logs, almost every time you're using log base 10. Almost every time. Okay? And so if you see a blank log, it means log base 10. Okay, and so that is super important kind of thing for us to understand. Maybe you want to write it down here. Log with no b is log base 10. And I guess, that's how we talk about them is we say log base 10 if we're talking about that small number. So B for base, if you will. So let's go look at number 1 here, okay? So a couple different things. We know that this is log with a little b of x, and we can see that this 2 here is our little b, okay? Same idea. We know that b is equal to 2, and we know that b is greater than 1 because of that. So this should be a growth graph, okay? Now, it's a log growth graph, so I'll sketch it and then we'll draw it over there. Should look like this. Should look like this, okay? Standard growth graph. We don't have any H's, we don't have any K's, we just have pretty much the regular old growth graph. Now, how is the log base 10, because this is a 10, different from the log base 2? Don't really worry about it too much. The log base 10 is going to be going to the right a lot faster than the log base 2, but it's kind of hard to tell anyways, and we're not trying to be too picky here. So let's go ahead and graph this. We just need a standard graph. So vertical asymptote. We need a graph that is going up and then right about 0, going to the right. Okay, that's a good enough graph. It doesn't have to be perfect. It needs to look like it's on the graph in the bottom, and it needs to look like it is going away from the asymptote on the top. Now, working with these, like I said before, all of our answers are going to be opposite of what they were before, okay? If you remember working with our exponential graph, we had domain, all real numbers, right? Every time the domain was all real numbers. We had the asymptote was, I guess I'll write it out. The asymptote was y equals k. Our end behavior, x goes to infinity, y goes to, for this growth graph, would have been infinity, and x goes to negative infinity, y goes to, we would be going towards the asymptote for this one, so it would be k, because that's what the asymptote would be k. And then the range would be y greater than k, okay, because all of these things, for this graph in particular, it would be 0, 0, 0. But, if we put a +3 here, now all these answers would turn to 3, 3, 3. So it was very easy to do. Literally, this template would get you the question right every time. Unless you had a decay graph, you would need to switch these two, right? But for the most part, this is good enough. This is going to do it for you. Now, we're going to have to do basically the opposite for a log graph, right? A log graph, which looks like this, domain is not going to be all real numbers. Your range is not going to be greater than k. Your end behaviors are going to be different. Your asymptote is going to be different. Okay, so it's going to be a lot different. But you'll notice some patterns and similarities as we get into it. So let's start with the asymptote, okay? Because we know that the asymptote is going to be the thing that's going to affect all of our answers. And so let's start here with the asymptote, okay? I know that my asymptote is a vertical line now. How do we write vertical lines? What do you guys think? X equals, okay? Vertical lines are going to be x equals. I heard this from a bunch of Algebra 1 students, right? They remember Hoy-Vux. Make sure that's a U, not an O. Hoy-Vux, which tells them that horizontal is y equals and vertical is x equals. Sounds like a Harry Potter spell to me. I'm not really into Harry Potter, but we'll deal with it. X equals. Okay, so this is going to be a vertical line. And then our number here is going to be 0. because it's obviously a vertical line at 0. Now this means that this number 0, this is kind of like my rock star number. This number 0 is going to be an answer to almost everything. Okay? So when I go to do my domain needs to be x greater than 0. Okay, now this is the inequality notation. And one thing that's really important is that I'm using x's here because I'm talking about domain. I'm not talking about range. So I can't use my y greater than. I need my x greater than. We could also write this as from 0 to infinity. But it's all very similar. Okay, and that's because my graph is on the positive side. My graph is not on the negative side. My range would be all real numbers because my graph is going down and my graph is going up. So my graph is everywhere, up and down. So my range would be all real numbers. And notice how this is opposite that it was before, right? It used to be all real numbers, y greater than 0. But I've had to swap these around because I'm doing log graphs, and it's basically the opposite. And lastly, again, I don't really care about x-intercept. Just go on Desmos if you want to figure out what the x-intercept is. As far as in behavior goes, we're looking at something that looks a lot different in behavior-wise than it did before. Okay? Beforehand, this was guaranteed to be a positive infinity. This was guaranteed to be a negative infinity. Don't write these down yet. But what that meant was on the right side and on the left side. Okay, and then these would be blank. And our question was kind of like up or down, right? On the right side, are we up and down? On the left side, are we up or down? And then obviously when we got to the exponential questions, we saw sometimes the answer needs to be k. Okay, but undoing all of that stuff, now we've flipped the blanks. Okay, so instead of certainly on the right and certainly on the left, this is a question, right? I don't know where. Maybe on the right, maybe on the left. But what we know for certain is this y stuff. Okay, so this y is saying up, and this y is saying down. So the question is now backwards. Instead of on the right side, what are we doing? Now it is, if you're going up, what is your x value? Okay, so which x values are we going up? We're going up, 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 up. We're going up over here. Okay, if I expect to be up at positive infinity, okay, where do I expect my graph to be up this high, right? Where's my graph going to be up this high? It's going to have to be over here. Okay, I'm not going up super fast, but that's the only chance I have to get up to infinity. And so my answer is going to be positive infinity, okay? Because that is where my x values are going up, okay? My x has to be getting bigger in order for me to be going up in this direction, okay? Now, this other question is the same thing. When am I going to be getting down here to negative infinity? If I kind of zoom out a bit, when am I going to reach this line down here at negative infinity? Okay, my values are basically, is it going to happen over here at positive infinity, over here at negative infinity, or perhaps is it going to happen in the middle at the asymptote? If you remember back to exponentials, one of the questions would have an answer of infinity, one of the questions would have an answer of the asymptote. Okay, and so the same kind of thing is going on here. Where can we expect to be going down? We can be expected to going down right here at the asymptote. And so our answer would be 0. Now, just like the first time you did in behavior, the first time that we're doing this kind of reverse in behavior is also pretty weird. But if you remember last week, when we were doing our exponential graphs, it was y equals k, y going towards k, y greater than k. 3 answers that were all basically the same number, all real numbers, infinity. Okay? Down here, instead of y, down here, we have the same thing. Okay? We have x equals 0, x goes to 0, x greater than 0. So we have the same thing, 0, 0, 0, the same kind of answer 3 times. We still have all real numbers. We still have infinity. It's just kind of everything's backwards from what we thought. Okay, we're still going to have 3 answers that all revolve around the asymptote, except for now, instead of it being y, it's going to be x, x, x. Cool. Let's go down. Let's power through number 2, and we're going to go way, way, way faster here. So bear with me. Number 2 is not that interesting. Okay. The only thing that's interesting about number 2 is that we have a decay question. Because we have this 1/3, because b is 1/3, because b is less than 1, we have a decay question. And so let's do a graph. Again, going really fast here. Oh gosh, so hard for me to do a straight line, right? We have this asymptote, which is a vertical asymptote, still at 0 because we have no h's, we have no k's, we have no movement. But our decay is going to make us go from the top down. Right, our decay is going to make us decrease. And again, it needs to make it look like it's along the asymptote, and then it shoots off about 0. Not being too picky about the graph. Obviously, if you want a perfect graph, you can look it up on Desmos and go from there. But here's an example of how fast you can solve these questions. Start with my asymptote. My asymptote is x equals 0 because it's still here at 0 and a vertical line is always going to be x equals. Now I know that this 0 is going to be my magic number. Okay? The 0 is going to affect my domain because I'm not less than 0 and I am greater than 0. So I'm going to put x needs to be greater than 0 or something like this. My range is always going to be all real numbers. And then already I'm basically done with the question just about. I just need to figure out which one of these is going to be my number 0 and which one of them is probably going to be infinity or maybe negative infinity. So looking here, remember, when am I going up? At what x values am I going up? I'm going up right here. So I'm going up at 0. When am I going down? When am I going down? I'm going down over here. So I'm going down at positive infinity. And again, I don't really care about x-intercept. So, again, I don't want to sound like a broken record. 0, 0, 0, all real numbers, infinity. Right? It's very repetitive. It looks crazy. The asymptote is kind of reigning supreme. And then kind of notice, I've had some students that kind of latch onto this and they do a really good job. I don't think this works for everybody, but it's x equals 0, x arrow 0, and x greater 0. So not only is it 0, 0, 0, but you kind of get one of each symbol, the equals, the arrow, and the greater than. It could be a less than if we had some really funky graphs, but it pretty much will always be a greater than. And so let's get into 3 and 4. Okay, now I want to talk about 3 and 4 at the same time. These are both on the back of your paper if you've got them, Both of these graphs are going to be growth. Okay, we have a base of 4 and we have a base of 3. So in general, both of these graphs will look like that. Okay, now we have some h's and we have some k's. We have some maneuvers here. And here is where logarithms have something that is more difficult than other parent functions. Okay, you have x minus 1 and you have x minus 2. And those look pretty much identical. Okay, they look very, very, very similar. But, in fact, this is an h and this is a k. Even though they look almost identical, I'm sure you guys are on to me now, but because the number 3 has parentheses, it is grouped with the x, and that makes it an h. Because the negative 2 does not have parentheses, it is not grouped with the x, and it is a k. Okay? This is a big difference. Okay? This is tricky. So, this would be an h, right 1. This would be a k, down 2. Okay? And that is super, super important. I'm telling you, the most of this stuff is very similar to last week. If you get your h's and your k's wrong, I mean, you're just blown up. The question's over for you. You've messed up. So take your time. Make sure you kind of figure this out. If you want to go back up here to the front and maybe write yourself a little note, right? H in parentheses, K, no parentheses. I mean, I don't know. Maybe that's a little redundant for you. Maybe that's too easy. Maybe you don't need to write that. But that's the difference, okay? The parentheses are hugely important, I promise you, in telling you whether you have an H or a K. There will be a question on the test. There's almost guaranteed to be a question on the SOL test. One of them that looks like this, and one of them that looks like this. And you've got to know the difference in the parentheses and what that's doing to your graph. So, all that being said, let's go back and let's start graphing these really fast. I need to graph this, but I've been moved right 1. So my asymptote at 0 is not at 0 anymore. My asymptote needs to be moved to the right 1. Yeah. Good call, Devin. So what I've written here, and it's terrible handwriting, but basically H is in parentheses. K has no parentheses. And again, it's easy for me to write so small because I can just zoom in. I'm sure it's hard for you guys to cram all those words there, but basically parentheses, parentheses, parentheses. Make sure that you're checking out those parentheses. Perfect. You're the man. So let's check out back to number 3. Remember, we've been moved right 1, and so that has shifted our asymptote 1. Okay? Our graph is still a growth graph. Our graph is still going to be growing in that type of direction. And our answers are going to be very, very similar to the question right above us, where we had 0, 0, 0, except for this time, we've got x equals 1. Because our asymptote has been moved to a positive 1. Okay, so now I can expect to have 1 for 3 answers, and I've already got 1 for 1 of the answers, right? I know that my graph goes up and down, so I know my graph will always have all real numbers range. My domain is going to have to do something with the asymptote, right? It's going to be x. It's going to be 1. Is it going to be greater than 1 or less than 1? Am I on the greater side of 1 or the less than side of 1? Obviously, I'm on the greater side. And again, the reason I'm writing these interval notations as well is it's always good habit to practice interval notation and just to make sure you know what you're doing. Both of these answers are fine. And lastly, our in behavior, you've got an up and you've got a down. When are you going up? I'm going up over here at infinity. So this answer would be infinity. When are you going down? I'm going down right here. that would be at my asymptote of 1. And then to do number 4, even faster, if we go down 2, that is not going to move. Whoa, Brown. No thanks. Going down 2 is not going to move my asymptote. Okay, if I take this asymptote and I move it down, it's still right where it was. Okay, and so this number 2 is not affecting our asymptote. Make sure you're cool with that. Right, we're still growth. The difference what this 2 does is going up. Instead of going up about 0, we're just going to go up a little bit sooner, right? We're going to go up about -2. Maybe it looks like that, right? So our answers are actually going to be exactly the same as our number 2 answers, because our asymptote is the same and the asymptote is the big difference. Now, the only difference between number 2 and number 4 is that this graph is a decay graph, and so my in behaviors are switched. But as far as number 4 goes, it's going to look very, very similar. So let's knock this out. Our asymptote, let's choose yellow, I guess. Our asymptote is going to be x equals 0. Don't care about the x-intercept. Our range is going to be all real numbers. Our domain is going to be x is greater than 0. Our end behavior, this means up, this means down. When are we going up? It would have to be here at infinity. When are we going down? It would have to be there at 0. There it is. So that is exponentials and logs. Here's the big thing that you have to kind of struggle with now, okay? You have to do a log question right after you do an exponential question. Okay, and that gets a little tricky to remember which one is exponential, which one is log, which one is a horizontal asymptote, which one is a vertical asymptote, which one is domain all real numbers, which one is range all real numbers. And so going back and forth makes things a lot trickier. There is still a lot of similarities, H's, K's, your B values, growth, decay. There is still a lot of similarities. The way these answers work is very similar. But keeping these straight is very important. The last thing I'll say, you have to avoid being the kid that thinks that there are 2 asymptotes. There is not 2 asymptotes. There's only one. This graph is still going up forever, okay? So do your best to avoid that. Remember we talked about this. If you don't see a number here, that means a 10. I know we kind of glanced over that, but for the most part, this is logs. For your homework, what I would recommend, if what you do to practice this, is do a worksheet where you have logs and exponents at the same time. Okay, and so that's what we'll be working on for homework. But really good job. This is graphing logs.